Okay, so now we're going to go over bearings. Now, a bearing is just an angle measure with respect to a compass. So we do need to know the cardinal compass directions here. And I don't care how you memorize them, but most people do. Never eat soggy waffles. You do need to have these memorized. Now, there are two types of bearings, a true bearing and a quadrant bearing, sometimes called a compass bearing. A true bearing always starts from the north line. And goes clockwise. And you know they're giving you a true bearing when there are either no letters or just N after the angle. So in this little example right here, our true bearing here starts from our north line and goes 30 degrees clockwise. So we would say that this is a bearing of 30 degrees, or they would write 30 degrees north. That's a true bearing. A quadrant bearing, however, starts from either the north or south line, whichever it's closer to, and goes towards east or west. Now, if it's a quadrant bearing or compass bearing, the N or S will be written in front of the angle, and E or W, east or west, will be after the angle. So in this example, our angle is closer to the south line, so we start with an S. From the south line, it's going towards the east. Right? This is north, this is east, south, and west. So it's going towards the east, so we say south 52 degrees east. That's our compass bearing, our quadrant bearing. So let's try it. We have south 35 degrees west, meaning we're starting on our south line and we're going 35 degrees towards the west. So from our south line, 35 degrees towards the west is less than halfway, a little over a third towards the west. So that is our quadrant bearing of 35 degrees. Same thing here. We're starting this time on our north line and going towards the east. That's towards the right. Now, from our north line, 80 degrees to the right towards the east is almost all the way. It's just 10 degrees short of the full 90. That is the second quadrant bearing of 80 degrees. And then lastly, we have 215. Now, this is a true bearing, always starting from the north line and always going clockwise. 215 is past 180. It is actually 35 degrees past 180. So from our north line, we're going to go 180 and then another 35 degrees to get our full 215 degree true bearing. All right, So let's try it. Now I'm going to leave example 4 for you guys to do. I will have the key for this posted, but I want to do the harder one, example 5. An airplane takes off from a runway at a bearing of north 20 degrees east. After flying 1 mile in this direction, the plane makes a 90-degree turn to the left. After flying 2 more miles in this new direction, what is the bearing from the airport to the plane? Now what I want you to do is I want you to try to draw this picture. I want you to pause this video, try to draw this picture. That's it. Don't try to solve it. Just draw the picture and then start this video back up. And of course, discuss with your group and continue this video. Okay, so the first thing you should have done was draw that bearing of north 20 degrees east. So I'm going to draw a little quadrant system. And if I'm going north 20 degrees east, that means from my north line towards the east, I go 20 degrees. From the port. Then they turn 90 degrees to the left. That means from this line, this angle that I created, I'm going to draw an angle that is 90 degrees. Now this line, the first part of their flight was only 1 mile, but the second part was 2. So the second line should be double the length of the first at 90 degrees. And it wants to know what is the bearing from where they ended up to where they started. This angle right here. That's what it's trying to find. Now we can't immediately find this though. We can't immediately find this because that angle is not it's not the entire angle on a right triangle. Instead, what you should have done is find this full angle. We'll call it X. Well, we'll call it alpha. Oh God. Maybe we'll call it X. I don't want to erase. We'll call it X. And subtract 20 from it. Now, if this is our angle, X is our angle, that means that 1 is our adjacent side and 2 is our opposite side. So from SOHCAHTOA, TOA is the only one with O and A, I'm again using tangent. Tangent of X is O over A. Now to solve for an angle, we have to do the inverse trig function. Tangent inverse. Tan inverse and tangent will cancel, leaving us with X is equal to the inverse of tan of 2. So here in my calculator, I'm going to do the inverse tangent, second tan of 2, and I get 63.435. But this is the full angle. I need to take this angle and subtract 20, to get my theta. I get 43.435. But they unfortunately want this in quadrant bearing form, in bearing form. So this angle is closest to our north line, so we're going to start with an N. 43.435 degrees, and it's going towards the west. So I end with a W. And I'm done.